So we've seen how we conduct the hypothesis test for this problem using both the p-value approach and the critical value approach. Right? Now let's do a follow-up question. The follow-up question asks us to conduct the test at 1% level of significance if the sample of 100 cars use a mean of 36. Okay. All right. So let's see how we do this problem. Now it's the same setup, right? And so when it comes to developing the null hypothesis and the alternative hypothesis, nothing changes, right? In other words, the null is still mu being greater than or equal to 40, and the alternative hypothesis is that mu is less than 40. Okay. Now we know that n is still 100, right? So we still have a sample of 100 vehicles. Sigma x is still 15. The hypothesized value mu sub 0 is still 40, but now x bar has changed, right? X bar in this follow-up problem is 36 as opposed to 37 in the original problem. Right? So with that information, we calculate the test statistic. So our test statistic z is equal to x bar minus mu sub 0 divided by sigma x over the square root of n. Okay. So in this case, we have 36 minus 40 divided by 15 over the square root of 100. So if you do the math here, you should get negative 2.67 for the test statistic. Okay. So far so good. Let's now look at the problem, the next two steps, right? So, and I'm gonna combine step 3 and step 4 together. Okay, so formulate the decision rule. And conclude. Okay. Remember that alpha is still 1%, which is 0.01. So we have the p-value approach, and then we have the critical value approach. And then what is the decision rule here? Remember that the decision rule for the p-value approach is that we reject the null if the p-value is less than alpha. Okay. And then for the critical value approach, we reject the null if the test statistic is less than the critical value, right? Where the critical value is equal to negative z sub alpha, because this is a lower tail test. All right. So now let's see how we find the p-value. Right? Remember the p-value in this case. This is a lower tail test. Right, so if you draw the normal distribution, if you put the test statistic right here of negative 2.67, then the area to the left of the test statistic is the p-value. Okay, so how do you find that area? All you need to do is you go into the z table, look for negative 2.67 on the margins, and then find the probability in the interior. So let's go ahead and do that. So you want to go to the z table, look at row negative 2.6, and look under column 0.07. That gives you a probability of 0.0038, right? Which means that our p-value is 0.0038. Okay. So now, given that p-value, what's going to be my conclusion? Remember, alpha is 0.01. So the p-value of 0.0038 is less than alpha. So our conclusion is that we reject the null at 1% level of significance. Okay. So now let's move to the critical value approach. Here, our critical value is negative z sub alpha, which is negative z sub 0.01. But if you look at the example we did earlier, we already know that negative z sub 0.01 is negative 2.33, right? So that's going to be my critical value. So what's going to be my conclusion in this case? In this case, my test statistic is negative 2.67, right, which is less than my critical value of negative 2.33. And so my conclusion is that I reject the null at 1% level of significance. Okay. Again, if you look at this problem, these are two different approaches, but they both get us to the same conclusion. So in a sense, it doesn't really matter which approach you use. You should know how to use both approach, but regardless of what you use, you reach the same conclusion. Right. By the way, um, let's talk a little bit right here about the interpretation of the p-value. Remember that the p-value is the probability that we obtain a test statistic which is as extreme as or more extreme than the value observed, given that we assume that the null is true, right? In other words, if you want to interpret the p-value, the correct way to say it is that the probability of obtaining a test statistic right, or a z-value smaller than our test statistic, smaller than our observed test statistic. Right? Of negative 2.67 when the null is assumed to be true. Is 0.0038 or 0.38%. Okay.